Question 9. Can you cite some examples where a false negative important than a false positive? And vice versa? Answer, dash. Example 1 FN. What if jury or judge decides to make a criminal go free? Example 2 FN. Fraud detection. Example 3 FP. Customer voucher use promo evaluation. If many used it and actually if was not true, promo sucks.
Question 10. Can you cite some examples where both false positive and false negatives are equally important? Answer, dash. In the banking industry, giving loans is the primary source of making money, but at the same time if your repayment rate is not good you will not make any profit, rather you will risk huge losses. Banks don't want to lose good customers and at the same point in time, they don't want to acquire bad customers. In this scenario, both the false positives and false negatives become very important to measure.
Question 11. Can you explain the difference between a validation set and a test set? Answer, dash. A training set to fit the parameters, i.e. weights. A validation set, part of the training set, for parameter selection, to avoid overfitting. A test set, for testing or evaluating the performance of a trained machine learning model, i.e. evaluating the predictive power and generalization.
Question 12. Explain cross-validation. Answer. Cross-validation is a resampling procedure used to evaluate machine learning models on a limited data sample. The procedure has a single parameter called K that refers to the number of groups that a given data sample is to be split into. As such, the procedure is often called K-fold cross-validation. When a specific value for K is chosen, it may be used in place of K in the reference to the model, such as K equals 10 becoming tenfold cross-validation. Mainly used in backgrounds where the objective is forecast, and one wants to estimate how accurately a model will accomplish in practice. Cross-validation is primarily used in applied machine learning to estimate the skill of a machine learning model on unseen data. That is, to use a limited sample in order to estimate how the model is expected to. There is an alternative in scikit-learn called Stratified K-Fold, in which the split is shuffled to make it sure you have a representative sample of each class, and a K-fold in which you may not have the assurance of it. Not good with a very unbalanced dataset. Perform in general when used to make predictions on data not used during the training of the model. It is a popular method because it is simple to understand and because it generally results in a less biased or less optimistic estimate of the model skill than other methods, such as a simple train/test split.
The general procedure is as follows. 1. Shuffle the dataset randomly. 2. Split the dataset into K groups. 3. For each unique group, A, take the group as a holdout or test dataset. B, take the remaining groups as a training dataset. C, fit a model on the training set and evaluate it on the test set. D, retain the evaluation score and discard the model. 4. Summarize the skill of the model using the sample of model evaluation scores. There is an alternative in scikit-learn called Stratified K-Fold, in which the split is shuffled to make it sure you have a representative sample of each class, and a K-fold in which you may not have the assurance of it. Not good with a very unbalanced dataset.